Hey, physical science, it's Wednesday, April 14th. We're going to do page 472 to 476. So on 472, we talk about chemical properties. Last time we talked about physical properties, this time chemical properties. And what is that? It's any characteristic of a material that you can observe that produces one or more new substances. So the example that they gave was flammability. Some people have said the word inflammable, which means it can burst into a flame without any ignition. But flammability means it has a capability of being burned. And so, here in my basement, I have some paint thinner, and it says on the side, "Be careful, this is flammable." And so then it also, if you've got alcohol or lighter fluid or any of those kind of things, they burn rapidly, and it produces new substances. Medicines, look at the picture. Medicines are in brown bottles. Why? Because the light can break down the medicine. So, do you know the difference between H2O and H2O2? Well, H2O2 is hydrogen peroxide. It's in a brown bottle because the light can break it down into water, and it releases oxygen when it does. On the top of 473, if you detect a chemical change, you can detect it by the smell or the aroma. Like rotten eggs, you can see it if it's rust. Sometimes if it produces bubbles, that means it is producing a gas. And if a rapid release of energy is evidence of a chemical change. Fireworks, you can see the colors because the metals are in fact oxidizing, burning in oxygen. And so what's happening there is releasing a lot of sound and light and probably a lot of heat. And so those are all evidence of chemical changes. There's a solid precipitate on the bottom of page 473. You'd had a clear colorless solution of lead 2 nitrate and potassium iodide, and they're both clear and colorless. And when you pour them together, it produces that yellow looking stuff and a brand new clear colorless liquid. So they're different products from what the reactants were. Okay, so flip the page. We're on page 474, using chemical changes. Well, you can go ahead and take the tarnish off of silver by applying a compound to it. You can go ahead and separate metals from their ores through a chemical process. Weathering, look at the top picture, that river flowing through the boulders kind of rounds them off and it kind of breaks them down, and that's a physical change. But on the bottom, the White Cliffs of Dover over in England is because this calcium carbonate that came from the seashells has broken down in acid rain. And it's formed this thing called calcium bicarbonate, and it releases a gas, a carbon dioxide gas. And so limestone is a chemical change, a change in the limestone. We've got caves around here that resulted from that. And all those little stalactites and the stalagmites. Stalact because ceiling, stalag because ground. All right. And conservation of mass, page 475. Garbage in equals garbage out. So what does that say? According to the law of conservation of mass, the mass of all substances that are present before the chemical change, known as reactants, equals the mass of all the substances that remain after the change, which are called the products. Reactants equals products. Okay, so let's go ahead and do that demonstration just for fun. I just rustled up a couple things together. We're going to throw some baking soda into this little bottle that I had in my basement. Actually, a gas collection bottle. Okay, sodium bicarbonate, sodium hydrogen carbonate, baking soda. And we're going to take, this is a classic illustration. This is vinegar, which is called acetic acid. It's only about 5% strength when you buy it at the store. 95% water is what you're buying in that bottle. Don't tell your mom that, she might be disappointed. Okay, let's try to get this in the bottle without activating the reaction. Because what I want to do is, I want to weigh it before, and then I want to activate it, No, I'll tell you what, I'll just wipe it on my pants. There we go. Get some of that acid, that acidic acid out of there. All right, we're going to slide it down in there. We're going to put the balloon on the top. This is that same balloon that I used in the last lesson. And we're going to set it on the balance, which is right here. You're going to have to trust me on this. But the whole thing weighs 223 grams, 223 grams, 223. You want to write that down? I will. 223. And so we're going to say garbage in. Whoops, let's try it again. Garbage in produces garbage out. So what do you think the mass after the chemical reaction is going to be? You're right, 223. So this whole system right there, that bottle, that test tube, the vinegar, the acidic acid, the sodium bicarbonate, and the balloon all weigh 223.06. Make the chemical reaction happen. Ah, you can see it's giving off some gas, huh? Come on. Come on, Mickey. There we go. Good old Mickey Mouse. And you know what it says right there? 223. Like I said, you're going to have to believe me when I said that it weighs the same. So that's the illustration on the bottom of 475. Let's do a problem. Example problem 1. When hydrogen reacts with chlorine, the only product is hydrochloric acid. If 18 grams of hydrogen react completely with 633 grams of chlorine, how many grams of hydrochloric acid is formed? What's 18 plus 633? 651. Duh. 651 go in, 651 come out. Let's do number 7. Number 7, methane reacts with oxygen. The products are carbon dioxide and water. So let's just go ahead and write that down, just in case you ever pass physical science and move on out to my chemistry class. So we're talking methane, that's CH4, plus oxygen, burning, yields carbon dioxide and water vapor. And they said that how many grams of water are formed? Question mark. If 24 grams of methane react with 96 grams of oxygen and form 66 grams of carbon dioxide, here's your equation. 24 plus 96 is what? 120? That equals 66 plus X. That's easy. Just subtract 66 from both sides, and you're going to get an answer of 54. 54 grams of water are formed. See ya. Oh, is there anything else? There was another demonstration. Let me do this demonstration. I'm going to go back to 474. Take a look at the White Cliffs of Dover. You know what this is? That's a seashell. Probably shouldn't have taken it off the sea, but I did. Don't tell anybody. And this is right here is hydrochloric acid. It's also known as muriatic acid. It's sold down at Lowe's. Cleans up concrete and stuff with it. Anyway, so I'm going to take this acid and I'm going to go ahead and drop a couple drops of it on the seashell. I want you to watch what happens. So I'm going to turn it over so I got the little cup there. Okay, do you see that? Here it goes. Maybe you can't see it. Can you hear it? No? It's bubbling. Can't see it though, can you? Thought I was going to make that work. Well, it bubbles because carbon dioxide is released. That's a chemical change. And so what geologists will do is they'll carry a little bit of this hydrochloric acid, dilute down in a little cup on their belt. And whenever they see a rock, they'll drop it on this rock and determine whether or not it has calcium bicarbonate or calcium carbonate in it, because it'll react with an acid, form carbon dioxide. See ya. Say